Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to our second lesson on the extreme values of a function. In the last lesson, we learned about critical numbers. Today, we will learn about the mean value theorem. The mean value theorem will be central to many of the problems we will solve in this unit. But in order to understand the mean value theorem, we must begin with a special case. It is called Rolle's theorem. It is named after the 17th century mathematician Michel Rolle. Formally, it is defined this way. Let f be a function that satisfies the following three conditions. F is continuous on the closed interval a, b. F is differentiable on the open interval a, b. F of a equals f of b. In this case, there is a number c in the open interval a, b such that f prime of c equals 0. Now that we have learned Rolle's theorem, we are ready to see how it applies to the mean value theorem. Observe this graph, students, and do your best to answer the following questions. I will be back in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us examine the answer to each question. The slope of the secant line is a simple formula. It equals f of b minus f of a over b minus a. This is the equation of the secant line. Y equals f of b minus f of a over b minus a times x minus a plus f of a. We can draw lines that are parallel to AB and passing through P, through R, and through Q. This is because given a line and a point not on the line, we can draw exactly one line which is parallel to the given line through the given point. Since two non-vertical parallel lines have the same slope, we can conclude that the slope of the tangent line is equal to the slope of the secant line. This is expressed by f of b minus f of a over b minus a. Did you manage to answer all of the questions? Good work! Notice that we can draw a line parallel to AB passing through P. This is because given a line and a point not on the line, we can draw exactly one line that is parallel to the given line through the given point. We will call this line CD. Assuming that f is a differentiable function, we can find the slope of the tangent line CD. The slope is equal to the derivative of the function f at the points of tangency. Let f be a function that satisfies the following conditions. F is continuous on the closed interval AB. F is differentiable on the open interval AB. In this case, there is a number c in the open interval AB such that f prime of c equals f of b minus f of a over b minus a, or equivalently f of b minus f of a equals f prime of c times b minus a. This is the mean value theorem. To illustrate the use of the mean value theorem with a specific function, let us consider f of x equals x cubed minus x, where a equals 0 and b equals 2. Since f is a polynomial, it is continuous and differentiable for all x in the set of real numbers. So, students, it is continuous on the closed interval 0, 2 and differentiable on the open interval 0, 2. Therefore, by the mean value theorem, there is a number c in the open interval 0, 2 such that f of 2 minus f of 0 equals f prime of c times 2 minus 0, where f of 2 equals 6 and f of 0 equals 0. F prime of x equals 3x squared minus 1, so f prime of c equals 3c squared minus 1. Then 6 equals 3c squared minus 1 times 2, which is 6c squared minus 2. C squared equals 4 over 3. So, c equals positive or negative 2 over the square root of 3. But c must lie in the open interval 0, 2, so c equals 2 over the square root of 3. We can use the mean value theorem to help us understand the fundamentals of differential calculus. If f prime of x equals 0 for all x in an interval I, then f is a constant on I. If f prime of x equals g prime of x for all x on an interval I, then f minus g is a constant. Either this is the case, or f of x equals g of x plus c, where c is an arbitrary constant. Let us test your understanding of the mean value theorem with an activity. We will say that f of x equals the square root of x on the closed interval of 0, 1. Does this function satisfy the conditions of the mean value theorem? If so, find all values of c that satisfy the theorem's conclusion. You can get started now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, everyone. F is continuous and differentiable on the closed interval f0, 1. So, the mean value theorem states that there is a number in that open interval such that f prime of c equals f of 1 minus f of 0 over 1 minus 0. The square root of 1 equals 1. So, f of 1 equals 1. The square root of 0 equals 0. So, f of 0 equals 0. If we find the derivative of f of c, we find that f prime of c equals 1 over 2 times the square root of c. So we have established that 1 over 2 times the square root of c equals 1. When we solve for c, we find that c equals 1 over 4. 1 over 4 is the only value of c that satisfies the conclusion of the mean value theorem. Good work, students! Today, we have learned about Rolle's theorem and the mean value theorem. Until next lesson, thank you, teacher. Thank you, students.